All right, we're going to be looking at 2.4 homework, the odd problems. Excuse my scribbling on this first one. I didn't want to rewrite. So just a little bit of homework help here looking at odds. Number one is 4x over 2xy. And in class, we kind of talked about a four-step process to dividing a monomial divided by a monomial. Step one is to sort of separate this fraction into things that are the same, right? So we're going to compare the 4 over 2, the x over x, and the scribble over y. The scribble is really nothing. If you look at the problem, it's actually 4x over 2xy, okay? And we're going to actually separate these into separate fractions. So we have 4 over 2. And we have x over x, or x to the first over x to the first. And then we actually have 1 over y, okay? This problem is a little easier than the other problems, so I'm not going to get into the subtracting on this one because I think it's a pretty straightforward question. If I divide 4 divided by 2, I get 2. If I divide x over x, or x to the first over x to the first, anything divided by itself is 1. And then 1 over y, let's just keep it as 1 over y. Okay? And remember, we can think about all of this as a fraction. So 4 over 2 we could think about as 2 over 1. And 1 we could think about as over 1, right? And doing it like this kind of allows me to figure out what's in my numerator and what's in my denominator. So my numerator is going to be 2 times 1, which is just 2. And my denominator is going to be 1 times y, which is just y. Okay? So kind of a straightforward question here of dividing a monomial divided by a monomial. Number 3, just a little more involved here. So number 3, we think about the coefficients kind of as their own thing, and then the a's kind of as their own thing, and then the b's kind of as their own thing. Okay, so we separate this out as negative 12 over 4. We separate this out as a to the 4th over a to the 2nd. We separate this out as b to the 10th over b to the 20th. Okay? From here, after we separate, then we're just going to subtract the exponents. So we divide the coefficients and we subtract the exponents. Okay, so 12 divided by 4, that's going to be negative 3 over 1. And I'm just going to go ahead every single time and leave it as a fraction because I know it's going back to a fraction. And then when I multiply, or when I divide a to the 4th divided by a to the 2nd, that's going to be a to the 4 minus 2. 4 minus 2 is 2. And when I divide b to the 10th by b to the 20th, that's 10 minus 20. 10 minus 20 is negative 10. And again, I'm leaving these all as fractions because I really want you to see what's happening here. When there is a negative exponent, I've got that exponent rule that says b to the negative n is actually 1 over b to the n, okay? And that's necessary because my final answer cannot have a negative in the exponent. So at this point, I need to use this rule and flip this to make the exponent a positive, okay? So this becomes negative 3 over 1 times a squared over 1 times 1 over b to the positive 10. And then once I do that, once I've got all the exponents positive, there's only one of each kind of base, then I can squish it all back together to one fraction. So across the top in the numerator, negative 3 times a squared times 1 is negative 3a squared, and 1 times b to the 10th is b to the 10th. And that's my final answer. Okay, let's do that again. Number 5. We have 5xy over 25 x to the third raised to the negative second power. Now remember in class we talked about the fact that we need to do this in order of operations. So I look on the inside of the fraction first and I simplify everything in the parentheses first. Okay, so I'm actually going to do this negative 2 that's on the outside of this fraction last. So it's just going to be hanging out. And on the inside of the fraction, I want to put together my coefficients. In a separate fraction, my x's. And then in a third fraction, my y's, right? So we're going to have 5 over 25 times x to the first over x to the third. Remember, if there's no exponent written, it's assumed a 1. Over y to the first. There's no y's in the bottom, so I'm just going to put over 1. And then I'm going to simplify, so I just, same thing, divide coefficients, subtract exponents. So 5 over 25, 5 goes into 25 5 times. So that's 1 over 5. X to the 1 minus 3. 1 minus 3 is negative 2. Remember, I'm subtracting exponents. And then there are no y's to divide, so it's just still going to be y to the first over 1. Then I look for anything that has a negative exponent in the inside. So this guy right here is going to get flipped because he has a negative exponent. So everything else stays the same. So this is going to be 1 over 5 times 1 over x to the positive 2. The whole point of flipping it is to make the exponent positive. And then y over 1. And then once I've got positive exponents, one of each kind of base, I squish it back together to a single fraction. So that's y over 5x squared, right? 1 times y in the top, 5 times x squared times 1 in the bottom, over negative 2. Now I'm going to do it again. I want to be able to square all of these, but I can't yet because I have a negative exponent. So the fact that this exponent is negative tells me that I need to flip this, okay? The fact that the exponent's negative tells me I need to flip this and make the exponent positive. So actually, this is going to become 5x squared over y raised to the positive 2 power. So that's how I deal with the fact that it's negative. Then I can just square everything in this parentheses. Okay, so I'll square. Mind you, I have 3 separate pieces going here. I'm going to have to square that 5. I'm going to have to square x squared. And I'm going to have to square this y to the first power right here. So I'm going to have to square each one of these separately. So I think about this as 5 squared. I think about this one as x squared squared. And in the bottom, I think about that as y to the first squared. And I need to remember an exponent rule right here. I need to remember the rule that says if I'm taking a base that is already to some power to another power, then I multiply this as n times m. So I'm remembering that rule here. Now, of course, with coefficients, I just square like normal. So 5 squared is 5 times 5, which is 25. X squared squared, that's 2 times 4. Excuse me, that's 2 times 2, which is 4. So that'll be x to the 4th. Over y to the first squared, which would be 1 times 2, or just 2. And there's my final answer. I know, kind of a long process. I'm showing you each and every possible step you could show. All right, moving on to number 7. Number 7 is 7a to the third b c to the negative fifth over 14 ac. Okay, so no outside exponents this time. And I think about my coefficients going together. I think about my a's going together. I don't have enough highlighter colors, but my b is by itself, right? And then I'm also going to have these c's, which I ran out of highlighter color, but they're going to go together as well. So I'm going to separate as 7 over 14 times a cubed over a times b over 1, right, times c to the negative fifth over c, and I'm going to go ahead and write both of those in the denominator to the first so that I don't forget that invisible exponents are 1. Now I simplify, and remember, simplifying just means divide the coefficients and subtract the exponents. So 7 divided by 14, that's 1/2. Remember, I'm subtracting exponents. So this is going to become 3 minus 1. 3 minus 1 is a to the second. I'm putting it over 1, just leaving everything as a fraction. That will help me later. B doesn't simplify because it's just b over 1, right? There's no b's to divide. And then I divide c's. Negative 5 minus 1, common mistake here. Negative 5 minus 1, signs alike combine. Negative 6. So this would be c to the negative sixth over 1. Okay? Remembering that those variables that have negative exponents, they're the ones that we're flipping to make positive exponents. So take the reciprocal, make the exponent positive. So 1/2 times a squared over 1 times b over 1 times 1 over c to the positive sixth. Once all the exponents are positive and there's one of each kind left, I'm going to squish it all back together. In the top, that's 1 times a squared times b times 1, which is a squared b. In the bottom, that's 2 times 1 times 1 times c squared, or excuse me, c to the sixth. So that's 2c to the sixth as our final answer. A couple of warnings before I move on to the next part. I'm looking at 6 and 8. 6 and 8 are actually a little harder than the ones that I work. So let me give you a hint without just doing all your homework for you. With 6, you're going to have to square the top first and then divide because the denominator is not squared. Okay? So first thing you're going to do is square the top, then you're going to divide by 16b to the negative 2. Just the same way we have been. And then 8's got a lot of crazy stuff happening here. So we have an exponent inside the numerator. So first I'm going to have to square the numerator, not z obviously, but the rest of it. Then divide, then cube at the end. Okay? So first apply this exponent, then multiply times z, then divide by 18x cubed z to the negative 2, then raise all that to the third power. Okay? Okay, so the last few problems in this homework assignment are dealing with a rectangle, knowing area of a rectangle and one side length. Okay, so question 9. Question 9 says, find the length of a rectangle. Okay, so here's a rectangle, and I don't know the length. If you are told the area is 12 and the width is 3. Now, guys, that 12 means that I have 12 1-by-1 blocks in here, right? So if I thought about this as 3 inside here, how would I make 12 1-by-1 blocks? Well, I would break this into 4, right? So if I did this, and then I did this, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that means the side is 1, 2, 3, 4 long. Well, this is easy because the number 12 is really small and the number 3 is really small, okay? I could have thought about it like this. I know area is length times width. And I told you area is 12. And I told you the width was 3, right? So this is 12 is equal to 3L. And then I can solve for L simply by dividing by 3. And that makes my length 4 that way. So it turns out that, and this is from your notes, that a rectangle, if I want to find the width, if I know area and length, I can take the area, divide by the length, and I get width. Or I can take the area, divide by width, and I get length, right? So for every single one of these problems, 9 through 13, all I really need to do is divide area by whatever dimension is given to me, and it gives me the other dimension. Okay, so let's look at number 11. Find the length of a rectangle if you were told the area is 24x and the width is 12x. Okay, so again, I can find length simply by dividing the area by the width. Okay, so the area is 24x and the width is 12x. And I think about these as separate pieces, right? So I divide 24 by 12 and I divide x by x. So 24 divided by 12 is 2, and x divided by x is 1. And so my answer to this problem is 2. And one more with you. One more. 13. Find the side length of a square. So this time we have a square, not a rectangle. If you're told the area is 9x to the 6th. Okay. So the area of a square is side squared. So what we're saying is that 9x to the 6th is side squared. Now this is a little bit confusing, right? Because maybe I don't know how to solve this problem. But I think if you think about it, you can make sense out of this. So think about the 9. These have to be the same length. Okay? So first question is what number multiplies by itself to get 9? And the answer is 3. And then the next question is what can I multiply by itself to get x to the 6th? Well, I know that if I start thinking about multiplying x, right? X times x, 1 plus 1, would be x squared. And it has to be the same thing, right? So x squared times x squared would be 2 plus 2, which is 4. Still not enough to be 6. X cubed times x cubed, 3 plus 3 is x to the 6th. So each one of these has to be x to the 3rd. So that tells me that the side length for a square with an area of 9x to the 6th has to be 3x to the 3rd. Now, remember I told you, little side note for all you brilliant peoples, I told you that square root and 1/2 was the same thing. So one thing that I could have done that probably nobody thought about is I could have said, okay, I know side squared has to be 9x to the 6th. But I don't want side squared, I just want side. So what if I raise both sides to a power of 1/2? Again, I don't really, it's fine if you don't know how to do this. But that's 2 times 1/2, that's just a side. This just means square root, right? So the square root of 9 is 3. And then 6 times 1/2 is also 3. So this is a way that you could have worked it that maybe you didn't think about. All right, guys, I hope this was helpful, and I will see you in class.